Welcome back. Today, we'll explore the 16 seniors of engine, what they are, how they work, where they're located, and what happens if they falter. These sensors play a crucial role in your vehicle's performance, and understanding them is essential for every car enthusiast. Okay, let's get started. Crankshaft position sensor measures the rotational speed and position of the engine's crankshaft. This information is crucial for ignition timing and fuel injection. Typically uses a magnetic or Hall effect sensor to detect the rotation of the crankshaft's reluctor wheel, generates electrical pulses as the wheel's teeth pass by the sensor. The number and timing of these pulses provide information about the crankshaft's position and speed. It's usually located near the crankshaft, often behind the crankshaft pulley or on the engine block. If its falter, engine may stall or have difficulty starting, poor performance, misfires, and rough idling. Camshaft position sensor. It monitors the position and speed of the camshaft. It assists in synchronizing the opening and closing of engine valves. Utilize similar technologies to the CKP sensor. Monitors the position and speed of the camshaft, typically by observing teeth or slots on the camshaft sprocket, typically mounted on or near the camshaft, often on the cylinder head or camshaft cover. Timing issues affecting ignition and fuel injection. Engine may stall or have difficulty starting. Throttle position sensor measures the angle of the throttle plate, helping the engine control unit ECU adjust the air-fuel mixture for optimal performance and efficiency. Contains a potentiometer or Hall effect sensor, measures the angle of the throttle plate or its position. The sensor's resistance or voltage output changes as the throttle plate is moved. Mounted on the throttle body where the throttle plate is located. Poor throttle response and hesitation during acceleration, transmission shifting problems. Mass airflow sensor measures the amount of air entering the engine. The ECU uses this data to determine the appropriate fuel injection and ignition timing. Employs various methods, including hot wire, Vane, or Kármán vortex sensors. Measures the volume or mass of air entering the engine. Typically uses a heated element, and the change in its properties, for example, cooling effect or airflow disturbance, is used to calculate the air mass. Usually placed in the intake air duct between the air filter and the throttle body. 1. Reduced fuel efficiency and increased emissions. 2. Poor engine performance and potentially stalling. Vane airflow meter. Similar to the MAF, it measures the incoming air, but it uses a different mechanism involving a vane to provide airflow information. Utilizes a vane that moves in response to incoming airflow. The vane's position, often connected to a potentiometer, provides information about the air volume entering the engine. Less common in modern vehicles. It would be in the intake air duct if present. Reduced fuel efficiency, poor engine performance. Manifold absolute pressure sensor. Monitors the intake manifold pressure, which is used by the ECU to calculate engine load and optimize fuel injection. Measures the pressure inside the intake manifold, often uses a piezoelectric or resistive sensor to detect changes in pressure. Located on or near the intake manifold or throttle body. Engine may run rich or lean, leading to performance issues, poor fuel efficiency, and increased emissions. Oil pressure sensor monitors the oil pressure in the engine. Low oil pressure can indicate a problem and may trigger warning lights or engine protection measures. Employs various technologies, including piezoelectric, resistive, or capacitive sensors. Measures the pressure of the engine oil. The sensor's electrical properties change in response to pressure fluctuations. Typically screwed into the engine block or cylinder head near the oil pump or oil filter housing. Risk of engine damage due to low oil pressure. Warning lights on the dashboard. Fuel pressure sensor measures the pressure of the fuel in the fuel system. It helps ensure that the engine receives the correct amount of fuel. Measures the pressure within the fuel system. Utilizes resistive or piezoelectric sensors to monitor fuel pressure. Located in the fuel system, often near the fuel rail. Poor fuel delivery, affecting engine performance, risk of stalling or poor acceleration. Intake air temperature sensor monitors the temperature of the incoming air. This information helps the ECU adjust the air-fuel mixture for different environmental conditions. Typically uses a thermistor or resistive element. Measures the temperature of incoming air. The sensor's resistance changes with temperature, providing a voltage signal to the ECU. Positioned in the intake air duct or inside the MAF or throttle body. Incorrect air-fuel mixture, affecting fuel efficiency and performance. Potential for engine knocking or stalling. Coolant temperature sensor measures the temperature of the engine coolant. It's essential for controlling the engine's operating temperature and preventing overheating. Utilizes a thermistor or resistive element, measures the temperature of the engine coolant. The sensor's resistance changes with temperature, providing data to the ECU. Often located on the engine block, cylinder head, or in the coolant passage near the thermostat. Poor engine cooling and potential overheating, incorrect fuel injection and emissions control. Fuel temperature sensor monitors the temperature of the fuel in the fuel system. This data can affect fuel viscosity and combustion efficiency. Similar to the coolant temperature sensor, it measures the temperature of the fuel using a resistive element. Found in the fuel system, typically near the fuel tank or fuel filter. Potential fuel delivery issues, reduced fuel efficiency. Oil temperature sensor measures the temperature of the engine oil, which is important for maintaining oil viscosity and engine health. Similar to the coolant temperature sensor, it measures the temperature of the engine oil using a resistive element, usually installed in the engine's oil sump or near the oil filter housing. Incorrect oil viscosity and lubrication, potential engine wear and damage. Oxygen O2 sensor monitors the oxygen content in the exhaust gases. The ECU uses this data to adjust the air-fuel mixture for optimal fuel efficiency and emissions control. Utilizes a zirconia or titanium dioxide element, measures the oxygen content in exhaust gases, generates a voltage signal based on the difference in oxygen levels inside and outside the exhaust stream. Positioned in the exhaust system, both upstream before the catalytic converter and downstream after the catalytic converter. Decreased fuel efficiency and increased emissions, engine performance and emissions control problems. Exhaust gas temperature sensor measures the temperature of exhaust gases. This is particularly important for turbocharged engines and emissions control. Utilizes thermocouples to measure the temperature of exhaust gases directly. Located in the exhaust manifold, downpipe, or exhaust system, depending on the application. Issues with turbocharged engines, potential damage to the turbocharger or emissions control problems. Nitrogen oxide monitors the level of nitrogen oxide emissions in the exhaust, assisting in emissions control. Uses various methods, including electrochemical cells or other chemical reactions, to detect the presence of nitrogen oxides in the exhaust gases. Typically installed in the exhaust system, often near the catalytic converter or diesel particulate filter. Increased emissions and potential failure to meet emission standards, reduced fuel efficiency. Knock sensor detects engine knock or detonation, which can be harmful to the engine. The ECU can adjust the ignition timing to prevent knocking. Listens for abnormal engine knocking or detonation sounds, converts acoustic vibrations into an electrical signal, which is then used to adjust ignition timing. Usually mounted on the engine block or cylinder head, in close proximity to the cylinders to detect engine knock. Ignition timing problems, potentially leading to engine knocking and damage. Poor engine performance and efficiency.
There you have it, a deep dive into the world of vehicle sensors. We've explored what they are, how they work, where they're located, and the consequences when they malfunction. From the crankshaft position sensor to the knock sensor, these sensors are the unsung heroes of your car's performance. If you found this video informative, don't forget to hit that like button and subscribe our channel. Leave a comment below with your thoughts and questions. Thanks for joining us on this journey through the world of automotive sensors. Remember, knowledge is horsepower. And we'll see you in the next video.